So hi there folks. So in this next video on college algebra, we're going to continue with our set of videos in factoring. And in this video, I think this part 2 or part 3 video, 3 parts video or 2 parts video, we'll see in the future what we can do. We're going to talk about factoring by grouping. So factoring by grouping is another factoring technique. So it can be explained using this kind of example. So see here that we have AC plus AD plus BC plus BD. So they are all unique terms. They cannot be combined anymore because they have unique factors. And say, for example, they have variables in it, so they cannot be combined. So what can we do is something like this. Since we see in the first two terms, both of them have A's there. So we can see here that we have an A here, we have an A here also. So, by common monomial factoring, we can get the A out of that. And then also on the second two terms, we have the B here and we have the B here. So therefore, by common monomial factoring, we can get the B out of there. But notice here that we have C plus D in this right-hand side now. We have C plus D here. That's C plus D. And also we have C plus D over here. C plus D. So this is now a common factor. Though it's not a monomial, but it's one group, okay, a one grouping of terms. So this is what we call factoring by grouping. And since by the same essence or the same concept of the common monomial factoring, we can get rid of this, we're going to take it out from the group or from the term. So we see that this grouping can be taken out. So we're going to get this, or rather it is common for both terms. So we can put this outside the parenthesis. So we have C plus D outside. This is it. And then the A plus B is over here. So this is your A and this is your plus B. This is your plus B. Okay, so I hope you got it there, how it is being done. I'm going to give you one example for that. So um let's put it there so that you can see. Okay, let's give one example. So as an example for number one, say we have 3xs, sorry, 3xs plus 6xt minus ys minus 2yt. So what are we going to do here? So we can see in the first two terms that we have a common factor of 3x. This is 3x here. Actually, this 6 is 2 times 3. So we can see that we have also a 3x over there. Okay, so what we're going to do there is we're going to take that out, that 3x. So what will happen here is we're going to take out the 3x. So this will become, I'm naming the 3x as a red pen, so 3x. Okay, and then I'm going to copy the rest using a blue pen. So what is left here if we're going to get the 3x, so we have s. And then what is left here if we're going to get the 3x, so we have 2 and t. So we have plus, it's plus because we have a plus sign here, plus 2t. Okay, now next, in the next batch of terms, we can see the common terms, or the common term here. Both of them have minus signs, so we can get rid of the minus one. We can take that out. And notice that they both have y's there. Okay, this has an s, but this doesn't have an s. This have a t or and a 2, but doesn't have that either. But they have a common minus sign. So we're going to take that out. So that will become minus, not 2, minus y. And then we're going to copy the rest, which is left there. So if we're going to get the minus y, what is left is s. Here, if we're going to get the minus y, what is left is plus 2t. Anyways, it is plus because we have taken out the minus sign. And this, maybe you're wondering, where is the minus sign here? So it was taken out. because we have a factor of -1. Okay, so notice here the blue pens, they are common in the two terms, so we can get that by the virtue of factoring by grouping. We can get that out, so we can say that s plus 2t times 3x minus y. So this is our answer for number 1. Anyways, by commutative property of multiplication, they can be written oppositely. So we can write it as it's just equal, or let's put the word or there. It can be written as 3x minus y times s plus 2t. So they're still the same anyways, do not worry. Okay, so that's for our first example for the factoring by grouping. Let's move to the next example. Okay, number 2. Maybe we can have more space there. Okay, for our number 2, let's have x squared minus 4y squared plus x plus 2y. Okay, plus 2y. Okay, so what are we going to do? Okay, what are we going to do here? So maybe we can, we can adjust and make all the x's beside each other and all the y's beside each other. Maybe we can do that here. So let's see. So we have x squared. This can be rewritten as x squared plus x minus 4y squared plus 2y. Okay, so what you're seeing here is that I've put together all the x's, put together all the y's. Okay, so let's see if we can do factoring by grouping here. So um we can get all the x's on this side. So if we're going to get the x, we have x plus 1. If we're going to get all the common is plus 2y. So if we're going to get that, what we have is minus 2y plus 1. So clearly we cannot use the factoring by grouping here because the groupings are unique. So they're not the same. So that's a bad step. Step number 2 is a bad decision. So how about this? Maybe you have something in mind like this. This one, can you remember any? Okay, can you remember any factoring procedure that has this two conditions? Can you remember anything? Okay, it starts with D and then O and then T and then S. Yes, that's the difference of two squares. So this is a square. This is also a perfect square, and they have a minus sign in between them. So we can actually perform difference of two squares here. So performing the difference of two squares in these two terms here, so what we have is, I hope you can remember the formula. So we have, just a refresher, x squared minus y squared is just equal to x plus y times x minus y. Order doesn't matter because via commutativity. So what we have is x plus 2y times x minus 2y. Okay, so that's for the difference of two squares. So we're going to put plus x plus 2y. Yeah, maybe let's put a line so that we won't confuse that. Okay, and there you go. And yeah, now I think you can imagine that we have a common group. You can see, hope you can see that this one x plus 2y, then this one is also x plus 2y. So we're going to take that out, both of them. So if we do, let me write that in the red pen. So x plus 2y is common, okay, times the group of, we have, um, oh, sorry, not this one, not this x plus 2y. My goodness. Um, not this one. This is x minus 2y. My bad. Let's erase that one. But instead, it will be this. Okay, I'm sorry about that. So we have x plus 2y, and then what is left is x minus 2y, and then what is left on this side is plus 1. I think that's the final answer. Okay, so yeah, this is the answer for number 1. This is quite a challenging one because we need to recall the difference of two squares here, but hey, we managed it. Okay, we manage it. Again, by commutativity, it's okay if this is written, if we are going to write this first, it's just okay. Okay, for the third example for factoring grouping, maybe we can stop by the fifth example or the fourth. Okay, for the third example, say we have 4ax plus 3bx minus 4ay minus 3by. So by grouping, I think we can see a common factor of x and x here, y and y here. So let's take them out. So getting the x for both sides. Okay, and then what is left? 4a x is taken out plus 3b. Okay, and then maybe in this example we can see that also there's a common thing between them, that's a minus and minus sign. So maybe we can our common term here is minus y instead of just y. Okay, since they're both negative. And then what is left on this side? So we have 4a. Okay, and then how about here? So we're going to take the y and the minus sign, so it becomes plus 3b. Okay, so furthermore, I think you can see it already that we have a common grouping here, a common group. So this 4a plus 3b is the same 4a plus 3b over here. So by virtue of factoring by grouping, we can take those groupings out. 4a plus 3b times what is left. So what is left? So we have x that is left. So we're going to take this out. Actually, we're going to take this out. So what we have is x minus y. And this is our answer for number 3. Okay, that's our answer for number 3. Okay, so I think we will stop here. Okay, instead of number 4 and number 5, we'll stop here for our last video, or rather our first video on factoring by grouping. We're going to continue this on the another set of video. Okay, so hope you learned something from here. Don't forget to like and subscribe. Okay, thank you very much.